Good afternoon, dear students. How are you? I'm good. Okay, let's move into the class. Today, we will discuss about gas laws. So, first gas law. Which one is the first one? Boyle's gas law. We have completed in that previous class. Today, we are going to study Charle's law. So, this law is explaining volume and temperature. So Charles, J.C. Charles, he is explaining the relationship between volume and temperature. Relationship between volume and temperature, V and T. He observed that the relation between volume and temperature from the gaseous molecule or the gaseous state, he observed and derived one law, Charles' law, that is a fixed mass of a gas at a constant pressure. At a constant pressure, fixed mass of a gas at constant pressure, the volume is directly proportional to its temperature. Okay, volume directly proportional to its temperature. Okay, so what is volume directly proportional to its temperature? Volume directly proportional to temperature. V directly proportional to T. Here he explained temperature in Kelvin. So here pressure is constant and number of molecule also it is constant. So what will be the difference? Volume and temperature will differ. The relation between volume and temperature, they will differ, but in the constant pressure and constant number of molecules present in that particular system. So volume is directly proportional to the temperature T, and we can remove this proportional with the proportionality constant. We already used this in the Boyle's law, proportionality constant K. Proportionality constant K. So we can write this like V is equal to KT. So Charles' law is explaining, if the temperature of the gas is increasing, volume also increasing. So this is the direct proportion. When volume the temperature increases, volume also increases. So it is explaining V by T equal to K. So K is a constant. You can take this T into this side. V by T is equal to K. We can write this for the same system at constant pressure, okay, but differing the volume and the temperature. That means if volume is increasing one level and the temperature is increasing in one level, the volume also increasing. So if the volume temperature decreases, volume will be decrease. We can write this in one system at a constant pressure. So pressure always is constant because varying the temperature and volume in it. So number of molecule also constant. So for the same system, differ in the volume and temperature, V1 divided by T1 equal to V2 divided by T2 equal to K. That means constant. Okay, so he explained this, or we can understand this in one experiment. For that, take a balloon is filled with gas and tightly band the end mouth of the balloon. Take the same size of balloon with the amount of gas which is present in that balloon also. Take care of that to be same. After that, take two water bath. Which one? First one contain ice water, second one contain boiling water. So two water bath. Take to water bath. First water bath filled with cold water. Second water bath is filling with hot water. Now take two balloons and put one balloon in the cold water. This is boiling water. Put a balloon on the surface of that water into the ice water. Put a balloon. Particles which is present in the balloon, in this balloon. And put another balloon into the boiling water. Okay, now leave that system for some minutes. You can observe the difference between that two systems. You can observe. So for, when you leave this cold water with the balloon, air filled balloon, now this balloon size, that means the volume, is decreased when the cold water, that means temperature decreases. Temperature decreases, so the gaseous particles in that balloon, that means the gas particles in the balloon, which is string. Why it is stringing? Because of decreasing the temperature, volume of that gaseous particles, that volume is decreasing. So the size of the particle is decreasing because of the volume. Because of reducing the size of particle, the volume of balloon also it is decreases. Then come to the second one, second system, with the boiling water with the balloon filled with gaseous particles. Now this boiling water means temperature is increasing. Temperature increasing. If increasing the temperature, also increasing the volume of the gas particles. So why it is increasing the volume of gas particles? When heating up any kind of molecules, if maybe the solid, liquid or the gaseous particle, they are getting or the absorbing the temperature and they move, they'll get expand. Okay, that is the general concept for all the molecules. So in the gaseous particle, they get the energy from the boiling water and they are moving fast. Why they are moving fast? Because they are not bounded together, they are freely moving molecules. Because of that character, this particles, gaseous particles are moving fast because of absorbing the heat energy from boiling water, because of moving fastly moving, and also it is expanding the size of molecules. So the molecules is present in the balloon, it is get expanding. Okay, they are get expanding. So because of particles fast movement and getting expansion of the molecules of gaseous particle, the temperature, the size of balloon will be increase. Okay, the size of balloon will be increase. Size of balloon will be increase from the original shape to the modified shape. So the size is increasing in boiling water. Because of size is increasing means volume is increasing. So temperature increasing, volume also increasing. Here temperature decreasing, the volume also decreasing. So the size will decrease. Size will decrease like this. Okay, decrease like this, but it is expanding. The size or the volume is increasing with the increasing temperature. This is the concept which is explained by Charles. So V by T is equal to K. That means V is directly proportional with T. Plot temperature and volume in a graph will give the graph like this. So in the variation of volume with the temperature at constant pressure is explaining in this graph. So in the y-axis we put volume V and x-axis T. From the graph we can easily understand it's given only the linear line. Linear graph line is increasing. So it is increasing when the volume is increasing. Temperature, when the temperature is increasing from minus to plus, it is increasing. Also increasing the volume of the system. You see this one, temperature. This minus 400, minus 300, minus 200, minus 100, 0 degree. So 0 degree is know that 273 Kelvin. So we can denote this is 373 Kelvin, 473 Kelvin, 573 Kelvin, 673 Kelvin. This is 173 Kelvin minus 200 means 73 Kelvin. Here near to this it is 0 Kelvin. 0 Kelvin. So the point which is denoted here 0 Kelvin is the point is minus 273 Kelvin. So the point at which degree at which temperature minus 273.15 degree Celsius at 0 Kelvin. At the whole we can take it is minus 273 degrees Celsius. That means 0 Kelvin. So 0 Kelvin means it is denoting the temperature minus 273 degree Celsius. So this point of 0 Kelvin or minus 273 Kelvin is generally known as it is absolute zero. Minus 273 degrees Celsius or 0 Kelvin generally known as absolute zero. Absolute zero. Okay, so this point is explaining the absolute zero or the the 0 point of the temperature. Absolutely, it is a 0 of the temperature. So come to the graph. From the graph you can explain this plotting against temperature and volume in x and y axis is explaining here with the straight line of increasing the volume with increasing temperature. But if you see from the decreasing way, decreasing the volume with decreasing temperature. Okay, so this graph is explaining the equation, or it is plotted by the equation y is equal to mx plus c. Y is equal to mx plus c. So which one is in the y axis? It is v. So put here v is equal to m. M is a slope line. Okay, slope line of the straight line. So from that you can take any slope and you can put the value of that. What is the x? X, in the x we put v, so it's become mv plus c. Mv plus x we put t, right? So mt plus v is equal to mt plus c. So temperature in degrees Celsius, we denote here T is equal to in degrees Celsius. In the degrees Celsius, we are denoting the temperature, and M, C both are constant. So we explained that T is in degrees Celsius. If we consider T in is equal to 0 degrees Celsius, T is equal to 0 degrees Celsius, then what will be V? The V will be V0. So the volume will become V0. Okay, that will become V0. So V0 is equal to C, because the whole thing V is equal to MT plus C. Now this T is become 0. This V M 0 plus C. Now this full term will become 0, right? So this is V0. V0. Why this is become V0? Because of the temperature T 0 degrees Celsius. So V0. So T 0 degrees Celsius, it is explaining V0. So V0 is equal to C. So getting slope from the straight line for the M will be M is equal to delta V divided by delta T. So therefore we can apply this value for the equation V is equal to MT plus C. Now apply this value. V is equal to, what is M value? Delta V divided by delta T into T plus C. What is C? V0. V0. Okay, V0 is equal to C. So we can apply that here, V0. Okay, so this is the equation finally you will get from that. Here number of particles present, number of molecules present in the system is constant. Pressure also it is constant. So because of that we can divide this full equation. This equation we can consider the equation number 1, number 2, 3, and this is 4. So divide this equation 4 with V0. Okay, equation 4 divide by V0. V divided by V0 equal to 1 by V0 into delta V by delta T plus V0 by V0 1. So how to write this? Like this we can write. Okay, so it will be the result V divided by V0 equal to, take this in here, so V1 by V0 delta V by delta T plus 1. This is equation number 5. This is 1. Charles and Gay-Lussac's was found, and they explained that under the constant pressure, the relative increase in the volume per degree, it is increasing the temperature. Is same for all the gases. So relative increase in the volume per degree Celsius is directly proportional. That means it is equal to 1 by V0 delta V divided by delta T, because of relative increasing the temperature per degree Celsius. Okay, temperature per degree Celsius. So it is equal with the 1 by V0 delta V divided by delta T. So V is equal to V0 This is equation 6. When relative relative increase in the volume per degree Celsius. Charles find out that expansion coefficient, it's approximately that coefficient is equal with 1 by 273, which means that constant temperature for a given mass, for each degree the rises in the temperature, all gases also it is expanding, so their volume at 0 degree Celsius. So he explained that the constant temperature for a given mass or the given molecules, all gas expanded at 1 by 273, 1 by 273. So their volume at 0 degree Celsius, at volume at 0 degree Celsius. So the graph is explaining that 0 Kelvin is pointed out in minus 273.15 degrees Celsius. So from that, this after the 0 degree Celsius, we have minus values. So when the value is become 273 Kelvin is become 0 Kelvin, that is indicating the temperature minus 273.15 degrees Celsius. Actually, in this volume, the zero volume V0, it not possible at the degrees minus 273.15 degrees Celsius. Physically, it is not possible. That's why Kelvin is discover one new scale, that is Kelvin scale. So he pointed out that 0 Kelvin or the temperature minus 273.15 degrees Celsius is called absolute zero. That is called absolute zero. Physically, 0 Kelvin is not possible, but by the theory, Kelvin is explained that the temperature is 0 Kelvin, and we can call that temperature is absolute zero. So in the previous stage, we only know the 0 degree Celsius and everything. So in the point of minus 273.15 degrees Celsius, Kelvin denoted it is 0 degree Celsius. So when we compare this Charles law with the Kelvin's scale with the Charles law, only the difference between these two, the position of 0 is shifted to the point 0 Kelvin. Okay. So by the Kelvin scale, we can say the absolute zero, freezing point and boiling point of water. So absolute zero, Kelvin scale, another one Celsius scale, Kelvin and Celsius scale. So for the absolute zero, it is 0 Kelvin, and here it is minus 273.15 degrees Celsius. Freezing point of water, that is 273.15 Kelvin. That means what? 273.15 Kelvin is 0 degree Celsius. So it is 0 degree Celsius. And the boiling point of water is 373.15 Kelvin. So what is 373.15 Kelvin? 373.15 Kelvin is denoting 100 degree Celsius. So this is 100 degree Celsius. Today you learn Charles law. Just read out the law and just try to understand the concept with the experimental part, that balloon experiment, and the explanation of the variation of volume with the temperature at a constant pressure. That means that graph, it is important. So draw it and practice it with the equations and find out what is absolute zero. So what is the participation of absolute zero in this Kelvin scale and in the Celsius scale? That table you should know the value of Kelvin and Celsius scale. So they will ask the question. There's a possible to ask the question about absolute zero and write the Charles law or define Charles law. Okay, students. So write this all the things, write down and learn and write. This is your work for today. Do that and study well. Thank you, students.